Hello everyone, my name is Selena, and today I would like to walk you through different type of four Scholar papers that I found online, and it's regarding to the language models for speech recognitions, which is the topic that I'm going to use for my project. So before we start, I would like to walk you through or provide um, a simple definitions for speech recognitions. Speech recognition is a process of converting speech signal to a sequence of words. Let's say if you trying to talk to Siri on your mobile phone and you try to command her to open a web browser, and that is how how a device can understand it is because of the speech recognitions that convert the wave signal into the text that it can be processed. So speech recognition is very famous around the global, and it's been used widely by different famous companies such as Google, Apple, or Microsoft. Now, before we begin, dive into deeper to the four Scholar paper that I would like to discuss about. I would like to give you a brief topic for this. And the first one is the hidden Markov model and speech recognitions. The second one is the predicting part of speech informations about unknown words using statistical method. And the third one is using a statistic context-free grammar as a language model for speech recognitions. And the fourth one is the language modeling by string pattern Engram for Japanese speech recognitions. Now let us jump to the Scholar paper number one. So before we dive deeper into the Scholar paper number one, I would like to provide you a highlight key that is in this paper. So the Scholar paper number one is using a model for speech recognitions, and that is called hidden Markov model. The hidden Markov model is a finite state automaton that use a probability as its weight, and it has a dual state that is the hidden state, and another state is called the observation state. So, for instance, as an easy example for understanding, let's say that John like to eat ice cream, right? And that we conduct an observations on him uh, to compare like his behavior of eating ice cream to the weather. And let's say that John is eating has been eating ice cream for uh 3 days within or 7 days within this month. So we can predict the next pattern of the same time that within this month it will be cold or hot, depend on what caused John to eat the ice cream. So this is the formula for the hidden Markov model. And now let's jump into the Scholar paper number one. So the Scholar paper number one is about how this hidden Markov model, or we can call shortcut as an HMM, have an effect on speech recognitions. So hidden mark, so a student from Department of Computer Science and Engineer from one of the Indian institutions at Mumbai wrote a report how uh, an HMM can be used effectively on speech recognitions, and his last name is Uchat. And he explained about the HMM model, how it's associated to math, and also he also pointed about the problems, how the problem HMM is affect has a negative effect or negative problems on the parsing path. So there is a solution that he also proposed to this is um, it's called the forwarding algorithm, Vitabe algorithm, or ball watch algorithms that solve the three problems. And the three problem is the evaluations problem, hidden state determinations or decoding, and learning problem. Like how you can train a device to learn the pattern to parse in the right way. So, in my perspective about this paper, is that I do agree that the model that he used, um, which is an HMM model, it is the best model because it's formularized with a non-complex math that can be solved effectively, as he said. The use of probability can help us to extend our further predictions as we tentatively observe the subject's behavior. One of the critical part about this paper is that UChat did not provide a clear enough overview of the relations of bomb bunch algorithm and the forward algorithm, since since like bomb bunch algorithm is the same as forward and backward algorithm, which it could make the reader could be understand that this algorithm is not related to each other. Now let us look at the Scholar paper number 2, which basically focusing on the part of speech tagging, and it's one of the model too for speech recognitions. So part of speech tagging is a grammatically tagging or a method of assign a word in a text to its corresponding part of speech, such as noun, verb, prepositions. Uh, this definition is provided by the Wikipedia. So, Scott M. Thede from Purdue University, located in West Lafayette in Indiana, um, he seems to use a method called part of speech tagging along with the hidden Markov model to parse the informations or the text. So the benefit of this is that it helps to speed up parsing system and also allowing the use of partial parsing. And how it handles the unknown word is that it uses a rule called affixation affixations rules that use the probability of word on their suffixes or prefix with their refinement methods such as entropy calculations, open class smoothing, and contextual information, or using suffix only. And the experiments that coming out shows that it has been provide up to 93% for three best tagging using the methods above. So my perspective about this Scholar paper is that using again hidden Markov model is also a good model for part of speech tagging because based on the evidence and statistic that provided by this paper, which is accuracy up to 93%. And the idea of using only suffix for the parsing is great also because grammatically we tend to use suffix to determine whether a word is a noun or a verb or preposition. So basically, suffix is the good way. But I also believe that if after using this suffix, and if we could apply prefix adding on to it, it would be providing a more accurate on estimating or predicting the next word because prefix um has its own advantages of pointing to find the word quickly and more fast if the part of speech has been already found by the suffix. So the next review is the review number 3, which is about this stochastic, or which you can call a probabilistic context-free grammar. So um, shortcut we can call as SCFG. So SCFG is the extensions of the context-free grammar, and that what the difference is that it just providing each product with the probabilistic value onto it. So in this way we can predict that which value is more um, more, which value is having more priority than the other value or chance. I Just a short reminder, what is a context-free grammar? By definitions that I found on the web, it is a set of recursively written rules or productions used to generate patterns of string. A context-free grammar consists of the following component: a set of terminal symbols, which are the characters of the alphabet that appear in the string generated by the grammar. And the Scholar paper number 3, which is about using a statistic context-free grammar as a language model for speech recognition. So the student from International Computer Science Institutions of Berkeley, California, provide a using a statistic context-free grammar and a probabilistic early parser algorithm to generate probability word transitions for speech recognitions. So it can help to reduce the error rates of word generations moderately. For instance, it's improved word from 34.6% of bigram to 29.6% SCFG. In this method, they have defined 3 usage of SCFG, such as using SCFG to smooth the bigram, using as the language model, or by combining the SCFG and the SCFG bigram together. So one of the methods that they have used is to smooth the bigram. In order to smooth the bigram, there are 2 ways. First method is to enhance an idea of Zeus et al. By using an advanced language model to generate random sentences to train a word pair modeling and adding SCFG to this method. The second method is use SCFG directly to generate the bigram by calculating its characteristic of Engram closed form, which is slower than the Monte Carlo sampling but more accurate. So the third method is using SCVG directly as a language model by combining the early parser and Verbi decoder, and also computing the prefix using the Verbi backtrace. And the other method is mixing SCFG with the SCFG bigram itself. The SCFG is the best at modeling long-distance dependencies and hierarchy structure. The SCFG bigram is best at local and lexical dependency. Together, they form a better enhancement of grammar and knowledge. The mix is determined the model equality weights. So my analysis for this Scholar paper is that using SCFG and combinations with other algorithms such as early parse for voice recognitions is a great idea to build such an application that is focusing only on one particular topic, such as for restaurant. This is not only provide an efficient way to tag the data, but also provide the reductions of error by small percentages greater than the base method. However, there is always a fallback. So one of the fallback is that if we use the SCFG to smooth the diagram, the accuracy of word parsing will be high, but the running time will be slow because it is in linear running time O of n. Another fallback is if there are multiple linguals, they will have to find a way to enhance because of the different of the grammar structures. Now, the fourth review is about the Engram. So, from Wikipedia, is an Engram is a model or a type of probabilistic model, language model for predicting the next item in such a sequence in the form of n-1 order model. Review for the Scholar paper number 4 is that it's talking about the language modeling by string pattern Engram for Japanese speech recognitions. So there are two students. Their names are Akinori and Masaki from Yamagata University from Japan has written a paper about using Engram to form a language model for Japanese speech recognitions, and that they said that Japanese words have no words boundary such as in English, especially the space or ending letter. Hence, it is hard to just parse words by word. So, in order to overcome this issue, and in order to use the Engram model, they first have to do the word segmentations by using morphemic analysis, but there are always issues into the place. Uh, Finally, they have to overcome with these issues by deciding to come up with another breakthrough by using the character string patterns as unit of Engram. So the proof from the experiment that they have conduct on the comparison between the models, um, effective of composite comparison on the between the model is, and also the effective on corpusci, also the applications to English text have shown that it's significantly improved in word frequency. This is the example of a Japanese sentence which doesn't have a segment in the word. It's just like straight. The meaning of a sentence is straight ahead, and there's no period for the ending words. So, in my perspective for this fourth review, is that I believe that using character string pattern as a unit of Engram is another good way for speech recognitions because they are simple in structure, fast, and provide the best solutions in parsing words. However, the author did not mention how likely that the errors can be occur or there will never be a failure. The author should also address about this matter because word accuracy is very crucial. This also means that they have to apply another level of algorithms such as using SCFG with its SCFG diagram to wait for the accuracy. So to summary, every enhanced voice recognition seems to share the same pattern of parsing text, the same language model, and that pattern is to utilize the mathematical probability, so to predict whatever come next. Because probability enhance the quality of uh, the qualities of parsing text faster, more accurate. And different models such as HMM, SCFG, Engram that we have seen in our literature review are using probabilities. They are likely better than one another depend on different scenarios. Hence, this would give me a better idea on how can I approach my own project for voice recognitions. Thank you for your time. If you have any questions, just let me know. Bye.